Next up will be Joshi from Chemical and Biomolecular Engineering, talking tonight on natural gas purification using metal organic frameworks. Jay.
So a lot of our world today revolves around natural gas. You can use it to produce electricity to power light bulbs, the plastics like on the backs of the chairs you're sitting in, and if winter decides to come this year, you might use it to heat your apartment or home. It's all around us, but you might not realize how complex natural gas is. Yeah, it has all these great things that we use for energy and commodity chemicals. There's also a lot of contaminants in that you need to remove. And probably one of the worst contaminants in here is hydrogen sulfide. And you know hydrogen sulfide really well if you've ever driven by a swamp. It's that pungent, rotten egg smell you get. And when you smell it, there's at a really low concentration, like parts per billion probably. But in a natural gas well, it's a lot higher. And there, it's not just a nuisance. It's toxic, it's corrosive, it's bad for the environment. You gotta get rid of it. And so what we do right now to do that works, but it's really energy intensive. And more often than not, it ends up releasing acidic byproducts in the atmosphere, causing things like acid rain. We just shouldn't do that. So what we're thinking was, well, what if instead, why don't we use something kind of like a sponge? Right, think about what a sponge is. It has a bunch of pores and holes in it. So when you wash something, you trap the dirt and grime in there. We want to do the same thing here for hydrogen sulfide. And it brings us to a class of materials known as metal organic frameworks, or MOFs. And MOFs are really neat in their simplicity. Because all you do is you take a metal node, an organic bridging molecule, and when you put them together, they self-assemble in these really porous cages with tons of empty space in them to store stuff. Another neat thing about MOFs is that there's tons of different arrangements they use to make them. And so we're afforded the ability to pick and choose what we want to make a MOF out of. And that's really powerful for us. Because now we're looking at using organic bridge molecules that will bond strongly to hydrogen sulfide. And what we're finding out in our research is that resulting metal organic frameworks will tightly bind hydrogen sulfide, but let things like methane or propane or other high-value chemicals in natural gas pass through for further purification. So essentially, we've made a selective sponge. Another thing to think about is stability, right? We can go back to the sponge analogy. What if you're washing something with a sponge and halfway through it falls apart in your hands? Is that any good? Of course not. You want something you can use again and again and again. It's the same thing here. And so it turns out that with different combinations of the metal and organic bridges, you get different stability behaviors in the resulting MOFs. And so we're trying to understand how these combinations will work, and so we can design a MOF that will remain stable in our highly corrosive environment. So all in all, our hope is that we could use these two guiding heuristics of stability and selectivity to guide our MOF design so that we can make a glorified sponge, basically, that will soak up hydrogen sulfide and make our energy and commodity chemical harvesting from natural gas safer and more sustainable. Thanks.